name is Rimsha Rafiq and I'm from Department of BS Biotechnology. Today the topic of my presentation is Thermo Gravimetric analysis, also known as TGA. Following are the contents of my presentation. We will study introduction, types, principle, TGA curve, instrumentation, factors affecting TGA results, advantages and limitations. Before studying about TGA, I'll let you know about thermal analysis. Thermal analysis is a branch of material sciences where the properties of material are studied as they change with temperature. Several methods are commonly used. These are distinguished from one another by the property which is measured. Some of them are thermogravimetric analysis, differential scanning calorimetry, derivative thermogravimetry, differential thermal analysis. Thermal analysis is also often used as a term for the study of heat transfer through structures. Many of the basic engineering data for modeling such systems come from measurement of heat capacity and thermal conductivity. This measurement provides information about physical phenomena such as phase transition, absorption, and desorption, as well as chemical phenomena including chemisorptions and solid gas reactions. TGA analysis is performed by gradually raising the temperature of a sample in a furnace as its weight is on a analytical balance that remains outside of the furnace. In TGA, mass loss is observed if a thermal event involves loss of a volatile component. Its principal uses include measurements of material thermal stability, filler content in polymers, moisture and solvent content, and the percent composition of components in a compound. Principal uses of TGA include measurement of material's thermal stability and its composition. The upper temperature used for TGA is normally 1000 degrees Celsius. Change in mass of or analyte is studied because of different physical or chemical transition. TGA is an analytical technique used to determine a material's thermal stability and its fraction of volatile components by monitoring the weight change that occurs as a sample is heated at a constant rate. TGA curve. The instrument used for thermogravimetry is a programmed precision balance for rise in temperature known as thermobalance. Results are displayed by a plot as change versus temperature or time and are known as thermogravimetric curves or TG curves. TG curves are normally plotted with the mass change in percentage on the y-axis and temperature or time on the x-axis. The reaction temperature and interval depend on the experimental condition. Therefore, they do not have any fixed value. Types of TGA transition. The measurement taken using TGA provides information about physical phenomena such as phase transition, absorption, adsorption, and desorption. This slide shows the block diagram of TGA. Instrumentation of TGA. The components of TGA instrumentation are recording balance, sample holder, furnace temperature programmer, controller, and recorder. Recording balance. A microbalance is used to record a change in mass of sample or substance. An ideal microbalance must possess following features. It should accurately and reproducibly record the change in mass of sample in ideal ranges of atmospheric conditions and temperatures. It should provide electronic signals to record the change in mass using a recorder. The electronic signals should provide rapid response to the change in mass. Microbalance is an instrument capable of making precise measurements of weight of objects of relatively small mass, of the order of 1,000,000 parts of gram. A microbalance is a tool used in laboratories and in scientific research with the capacity to make accurate measurements of the weight of very small objects, with a resolution in order of 1,000,000th of a gram. After the sample has been placed on microbalance, it is left for 10 to 15 minutes to stabilize. Recorder balance are of two types: deflection type instruments, null type instruments. Furthermore, deflection balances are of following type: beam type, helical type, torsion wire, cantilevered. lenses are of following type: beam type, helical type, cantilevered beam, and Torreson wire. Sample holders are one of the most critical part of the surface measurement in UHV system. The more dedicated the sample holder is, the better the measurement result. The result of the whole experiment can sometimes depend on the idea, design, materials, and precision of the holders. Crucibles. Crucibles should have temperature at least 100 K greater than the temperature range of experiment and must transfer heat uniformly to sample. There are different types of crucible. They are shallow pans, deep crucibles, loosely covered crucibles, retort cups. Furnace should be designed in such a way that it produces a linear heating range. It should have a hot zone which can hold sample and crucible, and its temperature must correspond to the temperature of furnace. The quartz liner provides an essentially inert surface to sample decomposition products. This furnace is ideal for coupled use with a MS or FTIR instrument that can uniquely identify the decomposition products from the TGA analysis. Thermogrammer controller. Temperature measurement is done in number of ways. Thermocouple is the most common technique. The position of the temperature measuring device relative to the sample is very important. The major types are: the thermocouple is placed near the sample container and it has no contact with the sample container. This isn't a good arrangement where low pressure are employed. Kept inside the sample holder but not in contact with it. This arrangement is better than that of because it responds to small temperature changes. The thermocouple is placed either in contact with sample or with sample container. This is the best arrangement of sample temperature detection. Recorder records the change in weight in y-axis and with respect to temperature on the x-axis. When the heating rate is high, the decomposition temperature is also high. A heating rate of 3.5 degrees Celsius per minute is usually recommended for reliable or reproducible TGA. Some of the other factors which may affect TGA curve are sample holder, heat of reaction, compactness of sample, previous history of the sample. Advantages of TGA. TGA can be used to evaluate the thermal stability of a material. In a desired temperature range, if a species is thermally stable, there will be no observed mass change. Negligible mass loss corresponds to little or no slope in the TGA trace. TGA also gives the upper use temperature of a material. Applications of TGA. The chemical or physical changes which are not accompanied by the change in mass on heating are not indicated in Thermo Gravimetric analysis. During TGA, pure fusion reaction, crystalline transition, glass transition, crystallization, and solid state reaction with no volatile product would not be indicated because they provide no change in mass of the specimen. Application of TGA. The thermogravimetric analyzer is an essential laboratory tool used for material characterization. TGA is used as a technique to characterize material used in various environmental, food, pharmaceutical, and petrochemical applications. Perkin-Elmer is the leader in TGA. Thermogravimetric analysis is ideal for characterizing the thermal properties of materials such as plastics, elastomers and thermostats, mineral compounds and ceramics, as well as for chemical and pharmaceutical products.